morning children. In today's class we are going to learn about logarithmic function. Logarithmic, I can say it is a reverse function for exponential. A little before we learnt about exponential function a power x. Suppose I take y is equal to a power x, I call it as exponential function. The reverse, log y to the base a, we call as a logarithmic function. In exponential we had a power m into a power n is a power m plus n. In logarithmic we have log mn equals to log m plus log n. Remember, product, here we add the indices. Here the product, we add the logarithm. Log mn becomes log m plus log n. Suppose it is log m by n. It will be log m minus log n. Product tells us add the logarithm and division tells us subtract the logarithm. We have a power m, the whole power n, we multiplied. The same idea, log m power n will come near n log m. So we have the three important properties: multiply, add the logarithm, divide, subtract the logarithm, power will come near. So log m power n will be n log m. The base they will mention in the question. It can be any number 2, 3, 4 like that. Everywhere put the same base. Can we change the base? Yes, there is a change of base rule. I have log a base b. How shall I change the base? I have log a, there is no change in that. Change the base into log c base b. Ultimately, I can remember the c and c will get cancelled. I am left with log a base b. So, log a base b is there. If needed, change some other base. So, you have to rewrite it like this. If I put c here, naturally I have to put c here and with the base b. This we call change of base rule. Another way of writing it is, if I don't want this in the numerator, bring it down. It will be c base b. When I bring it down will become b base c. Or in general, remember 1 by log b base c is nothing but when I take it to the numerator, it will be reversed c base b. These are the main properties which we will use in the exercise problems. What is log 1? Remember the value log 1 is 0. What is log 0? Log 0 itself is becoming minus infinity. Log infinity will become infinity. So these values tell me log is defined only for positive values. So whenever I have log x, the function, the domain is only positive values. So domain of logarithmic function, my answer is 0 to infinity. When I come up to range, look at the answer, log 0 becomes minus infinity and log infinity is infinity. So range I will say minus infinity to infinity, whereas domain is only from 0 to infinity. Remember, logarithm is defined only for the positive values. Let us list out all the formula that we have discussed so far. The very first property to remember, product rule, log mn becomes log m plus log n. Multiply implies add the logarithm. Log m by n is log m minus log n. Log a base a is 1, whereas log 1 becomes 0. Log 0 is minus infinity and log infinity equals infinity, implies logarithm is defined only for the positive values. Logarithm is defined only for the positive values, a very important property to remember, which tells me the domain is 0, infinity and the range is minus infinity, infinity. A very important property to remember in logarithm. The fifth property, we say log m power n is n log m, power rule. N, that is in the power, will come to the product. Log a base b, I will write a base c into log c base b, or bring it down tells me interchange. C base b, when I bring it down, it becomes b base c, and this we call change of base rule. So let us see once again all the properties and be thorough with before doing the exercise. Exercise 2.12, question number 1. If b is greater than 0 and b not equal to 1, y equals to b power x. Express in logarithmic form. Find domain and range. Given y equal to b power x. To write in logarithmic form, take log base b on both the sides. So this will become log y base b, and this will become log b power x base b. When I take logarithm, I know power will come near. So this is log x log b base b. Whenever same letter comes, it becomes 1. So my answer is only x. So I have log y base b equals to x. It is a logarithmic function. We know the domain is 0 to infinity, open interval, and the range is minus infinity to infinity. For a logarithmic function, domain is 0 to infinity and range is minus infinity to infinity, and that is the answer. Question number 2. Compute log 27 base 9 minus log 9 base 27. These are reciprocals. So let us find out this first. Log 27 base 9 can be written as 27 is 3 power 3 base 9. The next step, bring power near. So log 3 base 9, this power comes near. Reciprocal. Log 3 base 9 can come down as log 9 base 3. How to write log 9? Can be written as 3 square base 3. Bring the power near. So this will become 3 by 2 log 3 base 3. When it is same number, we get 1. So my answer is 3 by 2. Once I derive this, what is log 9 base 27? It is 1 by log 27 base 9, 1 by, here I get 3 base by 2, which I will write here 3 by 2. From the previous step, we write 3 by 2, which becomes 2 by 3. Once I know both the answers, substitute here. Log 27 base 9 minus log 9 base 27 is 27 base 9 is 3 by 2 minus 9 base 27 is 2 by 3. Taking LCM, cross multiply, it is 5 by 6, and that is the answer. Question number 4. Solve log 2 power 8x base 4 equals 2 log 8 base 2. Here I can write log 2 power 8x base 4 equals, the RHS is simple, which we can reduce. 8 can be written as 2 power 3 base 2. The very next step, log Power comes near. 3 log 2 base 2. 2 power 3 log 2 base 2 is 1. So it is only 2 power 3 which is 8. The left side we have log base 4 2 power 8x. From this I can write 4 power 8 equal to 2 power 8x. Logarithm, if I remove, it is 4 power 8 equals to 2 power 8x. Express the same base. 4 can be written as 2 power 2 the whole power 8. 4 power 8, I write 2 power 2 the whole power 8. 2 power 8x. 2 power 16 is 2 power 8x. Cancelling the same base, 8x equal to 16 or x is equal to 16 by 8, which reduces to 2, and that is the answer. Here 8 is written as 2 power 3. Power comes near. 2 and 2. Same number comes. It becomes 1. 2 power 3 is 2 into 2 into 2. That is 8. Whenever I have logarithm like this, 4 power 8 is nothing but this answer. 4 I rewrite 2 square. Multiply. 2 power 16 is 2 power 8x. Same base which you can forget. 8x is 16 gives us x is equal to 2, and that is the answer. Question number 5. If a square plus b square equals 7ab, show that log a plus b by 3 equals 1 by 2 log a plus log b. Since I want to show a plus b, try to write this as some identity. So given a square plus b square equals 7ab and I want a plus b. Try to write it as a plus b the whole square. So adding 2ab on both the sides. This becomes a plus b the whole square, and this becomes 9ab. The next step, I want only ab here. So bring 9 down. It is a plus b the whole square by 9, that is ab. Or rewriting this, a plus b by 3 the whole square. 9 is nothing but 3 square, which is ab. Taking log on both the sides, I can write this as log a plus b by 3 the whole square equals log ab. The next step, power comes near. So 2 log a plus b by 3 is log a plus log b. Product rule, power rule. Bring 2 down here. Log a plus b by 3 equals 2 comes down. 1 by 2 log a plus log b, and this is the result which I wanted to show, hence the problem. So we are just trying to write a square plus b square as a plus b the whole square to achieve the result. Then I have a plus b the whole square, which is 9ab. Because I want a plus b by 3, bring 9 down, write it as a plus b by 3 the whole square. Taking logarithm leads you to the result. Question number 6. Prove that log a square by bc plus log b square by ca plus log c square by ab equals to 0. Start from the LHS. We have written plus tells me it's a product rule. Remember, log m plus log n, I can write log mn. Applying the rule, plus symbol tells me multiply. So for all the logs together, write one log, multiply all this. A square by bc, b square by ca, c square by ab. See what you get actually. C square cancels. A square cancels. B into B square cancels. I am left with 1. Log 1 is 0 and 0 is the RHS, hence the problem. Question number 8. Prove that log a base a square into log b base b square into log c base c square equals 1 by 8. Starting from LHS, a base a square will not help me. Reciprocal. When I reciprocal, a base a square will be written as a square base a. Similarly, b base b square I write as 1 by log b square base b. The same idea, log c base c square will be written as 1 by log c square base c. The next step, power comes near. So 1 by 2 log a base a. Similarly, 1 by 2 log b base b. 1 by 2 log c base c. A base a, b base b, c base c. Same letter comes. All logarithms will reduce to 1. So we will write log a base a is 1. Using that idea, we are left with 1 by 2, 1 by 2, 1 by 2, which becomes 1 by 8, and that is the RHS, hence the problem. Question number 9. Prove that log a plus log a square plus log a cube and so on. Log a power n equals n into n plus 1 by 2 into log a. Starting from the LHS, log a we write as it is. Again remember, power comes near. So this will be 2 log a, 3 log a and so on, n log a. In all the terms, log a is common. Keeping it out as common, we are left with 1 plus 2 plus 3 up to n. This is sum of the natural numbers 1 to n. The formula is n into n plus 1 by 2, and that is the RHS. So we have arrived at it. The problem is very simple. Bringing power near, taking log a as common, the remaining leads us to n into n plus 1 by 2, sum of all the natural numbers. And so we get the RHS. Try to write n into n plus 1 by 2 and then log a, which is the expected result. 10th question. If log x by y minus z equals log y by z minus x equals log z by x minus y, then prove that x, y, z equals to 1. Since we are given 3 terms are equal, consider all are equal to k, a constant. From this, compare first and k. I get log x is equal to k into y minus k into z. The second equals to k tells me log y equals k into z minus k into x. The third one tells me log z equals k into x minus k into y. The question is x into y into z. If I want the product, add the logarithm. So, adding all this, we get log x plus log y plus log z equals ky minus kz, kz minus kx, kx minus ky. So, LHS plus symbol tells me multiply. So, log x into y into z equals ky, kx, kz. Everything gets cancelled. My answer is 0. Logarithm becomes 0 tells me whatever is here should be 1 only. We know log 1 is 0. So, log xyz equals to 0 tells me xyz is equal to 1. Question number 11. Solve log x base 2 minus 3 log x base half equals 6. This and this are almost same, but here the base is 2, the base is half. How shall we simplify this? We'll do it separately and check. Log x base half can be written as 1 by log half base x. That is 1 by log 1 base x minus log 2 base x. Log, we have interchanged these two, tells me I am reciprocating. Division tells me subtract. 1 by log 1 we know 0 minus log 2 base x. Again, if I take it to the numerator, 2 base x will go as log x base 2. Minus symbol will be retained. So, we have worked out what is log x base half and arrived at minus log x base 2. Put it back in the question. Log x base 2 minus 3 into log x base half we have attained as log x base 2 with minus symbol equals to 6. Minus and minus will get cancelled. 3 times log x base 2. This is 1 time log x base 2 together. 4 log x base 2 equal to 6, or log x base 2 equal to 6 by 4, that is 3 by 2. Whenever I have log x base 2 is 3 by 2, it is 2 power 3 by 2. 2 power 3 by 2 equal to x, or x is equal to 2 power 3 by 2. The meaning is 2 power 1 and a half. 2 power 1 is 2. 2 power half is root 2. We'll see this step again. 2 power 3 by 2 is nothing but 2 power 1 and a half. 3 by 2 is 1 and a half. 2 power 1 is 2. 2 power half is root 2. So what is my answer? It is 2 root 2. Given, solve. We must find what is x value. X value is 2 root 2 and that is the answer. Question number 12. Solve log x square minus 6x plus 65 base 5 minus x equals to 2. From here, I can write 5 minus x the whole square equals to x square minus 6x plus 65. Whenever we are given log, base power RHS equals to this answer. Simplifying this, this is a minus b the whole square. 5 square plus x square minus 2 into 5 into x equals to x square minus 6x plus 65. X square cancels, the remaining. 5 square is 25 minus 10x equals minus 6x plus 65. Bringing x to one side and number to the other side, plus 6x minus 10x is 65 minus 25 minus 4x is 40, or x is equal to 40 by minus 4, that is minus 10. So we have solved and found the answer x is equal to minus 10. In this problem, we use the formula log a base b equals to x tells me b power x is equal to a. Logarithm to exponential function we have changed. Question number 3. Log x base 8 plus log x base 4 plus log x base 2 is equal to 11. We have to solve the problem to find x value. X base 8, we can write 1 by log 8 base x. Same way, 1 by log 4 base x, 1 by log 2 base x equals to 11. So we have tried to bring same base so that we can apply the rules. Here the bases are different. I cannot use any of the rules. So bring x as the base so that we can simplify. Log 8 can be written as 2 cube base x. Similarly, 1 by log 4 can be written as 2 square base x plus 1 by log 2 base x, which is 11. Again power will come near. So 3 log 2 base x, 1 by 2 log 2 base x plus 1 by log 2 base x, which is 11. All log 2 base x terms can be taken common out. 1 by log 2 base x into 1 by 3, 1 by 2, 1 equals 11. From here, I can cross multiply. 11 log 2 base x. We have cross multiplied equals to 1 by 3 plus 1 by 2 plus 1. 11 log 2 base x equals 6 is the LCM. Cross multiply. It is 2 plus 3. 3 2s are 6. So we get 11 by 6 is 11 log 2 base x. 11 cancels. Log 2 base x is equal to 1 by 6, or I can write x power 1 by 6 equals to 2. X power 1 by 6 equals to 2, or x is equal to 2 power. This 1 by 6 goes to the right as reciprocal. X is equal to 2 power 6 is 2 into 2 into 2. 6 times multiply. My answer is 64. So given base, we try to bring the same. All these are 2 powers. Raise it to 2 powers. The powers come near, taking LCM, and as we cancel, log 2 base x is 1 by 6 tells me x power 1 by 6 is 2, or x is equal to 2 power 6, which is 64, and that is the answer. Question number 7. Prove that log 2 plus 16 log 16 by 15 plus 12 into log 25 by 24 plus 7 into log 81 by 80 equals to 1. Starting from the LHS, log 2 will keep as it is. Usually power we bring near. In this problem, let us bring the near number to the power. 16 by 15 power 16. Similarly, log 25 by 24 power 12 plus log 81 by 80 the whole power 7. The next step, log is simply given without any number near. Plus symbol tells me multiply. So log 2 into 16 power 16 by 15 power 16. 25 power 12 by 24 power 12. 81 power 7 by 80 power 7. All the logarithms plus symbol tells me just multiply. Now simplify this answer. See whether you get 1. 2 into 16 can be written as 2 power 4 the whole power 16. 15 can be written as 3 into 5. 3 power 16, 5 power 16. We are splitting. 25 can be written as 5 square the whole power 12. 24 can be written as 3 into 8. It is 3 power 12, 8 power 12. Again I can write 8 as 2 cube. So it is 2 cube the whole power 12. 24 is 3 into 8. 3 power 12. 8 is further written as 2 power 3 the whole power 12. 81. You can keep on dividing by 3. It is 3 power 4. So 81 is 3 power 4 the whole power 7. 80 can be written as 2 if I divide. It is 2 power 4 into 5 the whole power 7. 80 power 7 is 2 power 4 7, 5 power 7. Now try to write all as 2 powers. 2 into 2 power 64, 5 power 24, 3 power 28. Denominator 3 power 16 and 12. Together it is 28. 5 power 16 and 7. Together it is 23. 2 power 3 12s are 36. 2 power 4 7s are 28. This I can further write as log 2 power 64 plus 1 65. 5 power 24. 3 power 28. Denominator 3 power 28. 2 power 36 plus 28 is again 64 and 5 power 23. As we cancel, it reduces to log 65 64. As we cancel, it is 2 power 1. 28 28. 3 power gets cancelled. 5 power 24, 5 power 23, it is 5 power 1. Or I reduce it as log 10. And log 10, when we take the base 10, we know it is 1. Remember, log A base A is 1. Taking log 10 base 10 is also 1. So taking the base 10, this reduces to 1 and that is the answer. We have used two important formula in this problem. Log m power n is n log m. Power comes near. Near number will go to power. Log m plus log n is log mn. So we have used all the plus symbols for product. All the near numbers go to the power. Simplify it, raising to 2 power, 3 power and 5 power. We get the answer log 10. Log 10 is nothing but log 10 base 10, which can be considered as 1, and that is the problem.